Let's get oral. Let's get oral.
Hey! Was that too sharp? Did I wake you up? Oh, welcome to Let's Get Oral. Guess what? We're in person. Hey!
Wow. Finally.
I know.
This has been a long time coming.
Yes.
But this is hella fun. This is glad to actually do a recording with you.
I know. I get to see you and we don't have to worry about internet connectivity issues.
No dogs barking, no public transit or school buses.
Let's get oral.
Anyway, so good to be here today.
Yeah.
We're going to take on this nitric oxide story. I really wanted to take it on for a bunch of different reasons, but primarily because there is a huge opportunity here to talk about nitric oxide production, the oral microbiome, but specifically, and I think this doesn't get enough airtime, is the role of periodontal disease and nitric oxide and what's happening there exactly that kind of messes with this nitric oxide story. So I want to blow this out, and so I'm excited to talk to you, Jonathan. You've done some work in this space, pretty intimate with this story, so I'm going to let you talk us through some of that nitric oxide science.
Yes, thank you. I'm very excited to both share some anecdotes, but really provide some NO 101, to say the least, for this, what used to be considered a pollutant.
Right.
So before we dive into talking about the links between nitric oxide and oral health and the oral microbiome, first, let's take a step back and address the big question. What is nitric oxide?
What is it?
It's this small gaseous molecule, very, very common and abundant in nature and through processes of life. And it is a very multifunctional or factorial molecule that's involved in cell signaling and communication and regulating metabolic and cardiovascular functions too. And yet, while it is such a key biological compound, up until the 70s, we really never paid attention to its role or function in the human body, which, like many things, to me is just very fascinating considering how abundant and present it is.
That's wild. Wait, I have a question. Does it smell? It's gas, right?
It
Ew.
is. It's a gas. And spoiler alert, our mouths are very gassy, smelly places. But we'll save that for a whole nother episode and series on
Halitosis.
Yes, halitosis and gas talk. And so while this gaseous molecule does have a scent, it is something that is highly soluble and one that we commonly digest. And not just we as mammals, but what's fascinating is the role that the oral microbiome plays with producing / metabolizing the precursors of nitric oxide. But before we want to get into that, I just want to talk a little bit more about the NO pathway. And so you'll probably hear me interchange terms between nitric oxide or NO. They are one of the same, but I'll try to make sure I'm using the term NO for simplicity.
It is really fun to read research in this field because it looks like the paper is just saying no a million times.
All the time, yeah. My brain definitely has to remind myself I'm not dealing with this imperative coming from the author telling you no, it's NO here. So briefly, spend a couple minutes just giving a little bit more background on NO and really just the NO pathway and its role. It's actually, in large picture, it's just the nitrate NO pathway. And the reason why it is considered a nitrate NO is because the precursors for NO are what we tend to abundantly consume or produce through our diet and other metabolic processes. So, for example, whenever you eat like a high fiber diet, have some meat, maybe some shellfish, very, very many types of consumables, they innately actually have various levels of nitrate, which is NO3 or one nitrogen, three oxygens. And that nitrate almost immediately starts to interact both with our own saliva, the mucosal surfaces in our mouth, and more importantly, in my opinion, it also interacts with a lot of the microbes present, both the bacteria and fungi on our tongues, on our teeth, under our gums, etc.
So wait, what you're telling me is we chew food that has nitrite sources, and then we turn it into a gas with our mouths.
Exactly.
Ew.
And it's multiple ways this is happening. There's both the enzymatic way that this pathway moves forward through enzymes in our mouth and throughout the body, especially when it gets into our circulation. And then there's non-enzymatic ways. Say, for example, every time you swallow, you're taking, or your saliva is bringing down nitrate and also nitrites down to your gut, which is highly acidic. And that acidity provides an environment to then further convert the nitrite into NO.
Okay, but wait, who's the majority? Where is the majority of our nitrite being broken down, reduced?
That is primarily happening in the mouth.
Okay.
And in the saliva. And that's where they do then become part of our circulatory system.
I just wanted to be clear on if we couldn't do it in our mouths, could we get enough elsewhere?
Short answer is yes, but we will definitely get to that a bit later in more detail, because I think that story, again, is so fascinating considering how relatively short our history and knowledge of NO biology and physiology, and how certain practices or therapies have intervened or disrupted that pathway accordingly.
Excellent.
But to give you, beyond the mechanisms we just talked about here, some of the reasons why NO is so important for our health in biology is, as I mentioned at the top, it is a key signaling molecule and metabolite. And one of its key functions is for actually helping to regulate our blood pressure and vasculature integrity. So the short version, I'm really, really simplifying it here, is not as straightforward, but more or less, when you have high or sufficient levels of NO production, that tends to lead to having lower blood pressure. And this is especially true and has been observed in elderly populations, which, again, really looking forward to getting to that story and how certain interventions may help or have disrupted that over time.
So one of the things that I found interesting in this kind of deep dive into nitric oxide research is that predominantly in periodontal research, you see it as an indicator for periodontal pathology. You see an increase in the oral cavity of nitric oxide. And when you're reading through the literature, nitric oxide has anti-inflammatory benefits. And so there's this kind of disparity that happens when we talk about NO in the mouth and the abundance in the mouth as maybe being an indicator of periodontal pathology, and yet we need it so essentially for our heart health. You would think that a whole lot of NO in your mouth during periodontal disease would be good for your heart health, but we know there's heart issues in periodontal disease. So this is kind of why I wanted to do this episode, was really to blow out this discussion topic, because there's so much happening in that moment of pathology. But like nuts and bolts, we really want to appreciate the nitric oxide story because we know it's so deeply involved in heart health. So are there any other pieces that we should know biologically before I dive into the microbiome of the oral cavity?
Yeah, so not only does this pathway, and particularly NO, play a key role as for maintaining healthy blood pressure and blood flow. It is also capable of inhibiting platelet aggregation.
Oh, right.
Right?
Platelets.
You've mentioned reducing inflammation and what that looks like throughout different parts of the body. So I don't think that could be underappreciated. And it also can provide protective functions to tissues under states of hypoxia, right?
Right. Well, and to like piggyback onto that platelet story, George Haji Shingalis at University of Pennsylvania has done a ton of work on complement and platelets. And so that is like a whole area of research as well in the periodontal pathology. So nitric oxide, you're telling me, is key for reducing that platelet activation. Okay, excellent.
Absolutely. So the too long don't read version is NO is essential for maintaining a healthy life and having that being managed with our both habits and routines, and what that looks like also when we talk about the oral microbiome and that link, which I think is where both you and I, Camille, Black Bear, we get pretty nerdy about and excited when we start to pivot to such a topic. But could you highlight a little bit more about the relationship between NO metabolism or NO production with the oral microbiome?
Yes, let me do it. Okay, so most of the nitrate reducers in the oral microbiome are going to be located on the dorsal tongue. Yeah. And so the commensals that we're talking about here is predominantly the Veillonella species, Actinomyces, Haemophilus, and Neisseria are going to be the most abundant for the nitrate-reducing species in the oral cavity. And I know, Jonathan, you've done some work with Veillonella. Maybe you could share that, pepper that in.
Yeah, I think two things. It's interesting seeing who pronounces Veillonella as Veillonella versus Veillonella. I will not debate.
Tomato.
Yeah, exactly.
Okay, all right.
So we're talking about the same thing. But the Veillonella species have been a particular interest for me because that is a family of, or a genus of strict anaerobes that I really focused on throughout my PhD work when it comes to understanding its role and relationship with other strict anaerobes in the oral microbiome, and particularly oral biofilms. And then for me, even more interesting, the role it played in either monitoring or managing the abundance of oral fungi, such as Candida albicans and whatnot. And so when
so Candida albicans, just for the record, is a normal fungal species that can be found in the mouth, hopefully in lower abundance, right? Am I right? Say I'm right. Okay.
Correct.
And then if it's in high abundance, there's a number of issues, but I mean, we typically think of something like thrush.
Correct.
As an issue. Just wanted to highlight a common ailment that we may have all experienced either with our kids or with ourselves.
Correct. And so Candida was the model organism I worked with throughout my PhD. I was really fascinated of which microbes in consortium of the oral cavity had various relationships with this yeast, whether it was antagonistic, synergistic, mutualistic, and everything in between all of those. And the Veillonella species really caught my eye because when you look at models or pathologies such as caries or cavity formation, it seems pretty straightforward on the surface because you eat sugar, that sugar is broken down into acids such as lactate, and then that causes erosion of your enamel. A lot of that sugar metabolism being broken down into these acids is done by components of the oral microbiome, various streptococci.
Like strep mutans is really who gets the most blame usually.
Yes. Usually it's the sugar consuming or the technical and saccharolytic bugs. Veillonella, while it is an abundant consortium of species found normally in the mouth, they primarily use lactate as their carbon source. They do not break down and consume sugars such as sucrose or glucose and whatnot. So they've evolved to have this relationship with streptococci and other saccharolytic bugs in these environments to use the byproduct of sugar metabolism that produces lactate, and then they use that lactate for energy to further break down into smaller acids that aren't as corrosive to our teeth.
Cool.
So
you want Vianella there.
a lot
That's
of
your
times,
friend.
Yeah, and in a lot of ways, Vianella, the presence and the right abundance and diversity of Vianella is usually important when it comes to various sites of the oral cavity, especially when we're talking about the surfaces around the teeth and between the gums and teeth.
Got it.
Right? And while they get their energy from lactate as its carbon source, Vianella are also very essential when we're talking about the NO story because they've evolved to be highly adapted to reduce nitrates and to nitrites for electron movement.
Right.
So long story.
Energy.
Yeah, exactly. And so again, not wanting to get dirty into the difference between aerobic and anaerobic respiration, but Vianella are strict anaerobes. Therefore, they do not utilize or tolerate oxygen.
Right, but so typically when we think of periodontal pathology, we think anaerobes bad, but in this case, good. Got it.
Yeah.
I think there's a lot of nuance to the oral microbiome that we don't talk about enough, and that is that with the oral microbiome, it's all about a healthy balance, right? Mm-hmm. And I did want to kind of bring those pieces forward because Vianella is that strict anaerobe. There are good anaerobes, and I don't necessarily think the bad ones that have been tossed around like Porphyromonas gingivalis or Fusonucleatum, for example, Fusobacteria nucleatum, or we all call it F-nuke.
Yep.
But these are species that have historically gotten a bad rap. But hear me out. Here, the oral microbiome, when we're talking about nitrite and nitrate reducers, when they look at the full microbiome story on that dorsal tongue, we see communities that involve streptococcal mutans and F. nucleatum that don't actually reduce nitrate, but they do reduce nitrite. And F. nucleatum has a key role in the biofilm formation to make sure we have enough of those nitrate reducers in the biofilm. So it basically helps you to proliferate a biofilm that is healthy in producing nitric oxide. So
you're telling me if we don't have consortium members like F-nuke
yes,
or Vianella or a combination of them that are collectively capable of reducing nitrate to nitrite and then subsequently nitrite to NO,
yeah,
we've most likely has disrupted that entire pathway that's key for, say, cardiovascular
heart health, right,
and whatnot.
So the disparity in this discussion often comes from, we know in periodontal pathology, we see an increase in F-nuke, and we like to blame it for being a mid to late colonizer and helping other late colonizers like Porphyromonas gingivalis gain hold. And while that is inherently true, there's so much more going on. So there's always been a discussion in the back end around getting rid of our periopathogens, but inherently, as we discover and deep dive into the oral microbiome in all its functionality, we're discovering that we actually need these key species. And so how can we, do our oral hygiene and navigate this complexity in a way that is healthy and creates balance instead of distortion?
I know that the title says NO to mouthwashes. We didn't really talk about mouthwashes. But we talked about oral care products,
right,
like at large.
Right. There was a mouthwash study. There have been actually a couple mouthwash studies to show that over-the-counter mouthwashes will impact that nitric oxide pathway. The granular research on the oral microbiome itself, I don't think has been very well studied with over-the-counter mouthwashes, but certainly any antimicrobial therapeutic should be suspect because the oral microbiome is sensitive to environmental factors. So again, let's move away from antimicrobials. We know that, we need them in very specific pathologies, but we don't need them in the oral cavity. There's other ways to get to health, and I think we need to explore those more fully.
Yep.
And so I think that's a great segue to start talking about what we've been doing antimicrobially and how we have maybe learned some hard lessons trying to target these periopathogens, quote unquote, to help us get back to a healthy situation.
Yeah, I'm going to say it. Absolutely.
Absolutely. That's our key word, folks.
Yeah. And so, I think taking a historical look at the NO story and then even taking a step further back of the role of antimicrobials throughout the 20th century versus our understanding of and relevance of NO, it makes sense why things may have played out the way they did.
Well, sure. I mean, like
right.
in the early 1900s, we started looking at bacteria, understanding their role in disease and targeting them and creating antibiotics.
Right.
It was a game changer, and we learned a ton, and it was effective, and people lived longer, and they lived through childhood more effectively. But we're starting to now see some maybe not so great outcomes.
Right.
So let's get into that.
For example, let's jump back in time to the 50s, right? So post World War II, a lot of things have changed throughout the world, obviously, at that point. But focusing on the health side, you had a lot of, the pharma industry, I think, was really getting its legs and getting at a pace of being able to produce molecules. And whether we're talking about like Andrew Huff, and I'm not even going to start talking about psychedelics because that is a fun topic, but focusing on oral health and antimicrobials, one of the key antimicrobials that came out after World War II was chlorhexidine. This was a molecule discovered by the Imperial Chemical Industries from out in the UK, and they were actually originally searching for anti-malarial agents to treat that condition. And so this was originally used as a broad spectrum antimicrobial targeted for that category. However, in the 70s, it was introduced into hand soaps, both sand bars and liquid soaps.
Now that feels familiar.
Right. And this was both used like in hospital settings, and it also became available commercially.
I mean, to be clear, it is still used as a skin prep today and is very, very effective, way more effective than something like ethanol, which has an evaporation that then negates its purpose. So chlorhexidine has a lasting effect, which is great when you need to really sterilize an area and keep it clean.
Yeah, and another reason why it was really attractive and efficacious for its intended function is very low toxicity for us as humans for using it. So we could use it regularly and repeatedly with little cause, at least at the time, known of harm. And as Camille mentioned, it also has the ability of hanging around a bit longer. It doesn't just evaporate or disappear real quickly, having a short half-life. In the context of oral health, when it was introduced into oral delivery systems such as mouthwash, it was found that chlorhexidine was able to adhere or bind to our oral tissues for extended periods of time. So, for example, imagine you wake up, you do your oral care mouthwash or a routine that includes a chlorhexidine-based mouthwash. After using that, it could provide protective functions for like 10 plus hours due to its ability to adhere to our gums and whatnot.
That's crazy. But I'm going to pepper this in because Frank Scanapiecco, who's at University of Buffalo, was really thoughtful in his approach to sterilizing equipment like intubation tubes so that when you intubate somebody, you would sterilize it because it was found that periopathogens, for example, could lead to really terrible pneumonia infections. And so there was this push to pre-treat these tubes going into us during the intubation process with chlorhexidine to reduce that opportunity. And we thought that was all fine and good.
Right.
Something went wrong. What was that?
Dun, dun, dun. So,
Oh, no.
Right. So again, with the history lesson, right? This in the 70s, it was introduced in the oral care products. It just completely exploded in that entire category for its applications. It's obviously still used today. Getting into the 21st century, then it started being applied to catheters, as you said, intubation tubes. It's essentially almost like the standard care applicant to essentially a foreign object if it was going to be used in a hospital setting or as a wash agent for either your skin/mouth.
Well, and people who are in the hospital in critical care are often reticent to have oral care deployed on them, meaning if somebody's coming at you with a toothbrush, you don't want it because you feel terrible and you don't want to be violated any more than you already are in a hospital setting. And so there's a lot of resistance. There's also a lot of, caregivers that it's just not worth the trouble. And so we know that there's a problem in getting oral care effectively to these patients. And so chlorhexidine has been widely used on a sponge to kind of help mitigate the biofilm. And so, again, widely used, very prevalent.
Now, some people might be listening. I thought this was an NO episode, right? And I promise, this is where historically, it does make sense for how maybe this disconnect happened in the oral care space, because research actually looking at the biological roles and relevance of the nitrite NO pathway in oral care didn't really even start until the late 70s, if not mid 80s. And it took until really the last 10 to 15 years to truly start to get a broader appreciation of the role NO plays in our biological health. So when you put those things together collectively, the silent alarms about NO or the lack of NO in our health and our applications didn't start sounding off until compounds or molecules like chlorhexidine essentially became the standard of care, right? And to me, it's fascinating how that timing did play out, and in some cases, probably really unfortunately, because there are now observational studies that do show for what there's healthy people who have used chlorhexidine that leads to them having higher blood pressure after just a week's use. There are studies that show people who've been hospitalized and given chlorhexidine potentially having higher rates of mortality linked to cardiovascular health or disease. And so now both dentists and other healthcare practitioners and researchers have started to look at this intersection between the nitrite NO story and the way we go about antimicrobial applications for health. And so when we talk about, say, NO and perio versus NO and cardiovascular health, while we might be talking about the same compound, we view it in different lenses, whether it's considered beneficial or a bad biomarker or signal.
Right. Okay, so to add to that, chlorhexidine database is that we found in microbiome studies that when you use chlorhexidine in your mouth, you get a depletion of those specific nitrite reducers. And so that was the key take home and why we're now kind of walking back on that therapeutic application. So, talking about treatment is tricky because our kind of normal go-tos are starting to look not so great. But I do want to kind of talk to that piece of nitric oxide being increased during periodontal pathology, and yet we have a heart health issue. So when you look at periodontal patients, they actually have a decrease of nitric oxide in their serum. And why we know that the periodontal, like F-nuke, for example, is proliferating all of these nitrate reducers in your oral microbiome. Why then is that not being given to the serum in the healthy way it was before? And that is largely unexplored. We have a lot of theories, a lot of real-world principles that we can rely on to understand why this might not be happening. But nitric oxide is, basically a reactive oxygen. And in periodontal pathology, you also have inflammatory cytokines and inflammatory proteins that aid the production of reactive oxygen species, ROS we call it. ROS can combine with nitric oxide and create this hyperreactive, what is it, what is it called?
Yeah.
I can't say it.
I know what you're talking about.
Anyway, it's this very reactive oxygen species that then is used up immediately, and it can't actually transit to the serum. And so that's what's happening in periodontal pathology is there's an inflammation cascade coupled with that nitric oxide production that then just becomes hyperreactive and doesn't translate into the vasculature like it should. So if chlorhexidine, kind of our tried and true periodontal therapeutic, is off the table now, because if we use chlorhexidine on a periodontal patient who already has a lower NO in their serum, we don't want to take away their nitrate reducers even more. What we need to do is fix that inflammation piece to correct and get that nitric oxide to the serum. So that's kind of how we should be thinking about periodontal pathology and the relationship to the nitric oxide story. It is of note, we should talk about how we treat cardiovascular disease with regard to nitric oxide, because standard of care currently is to give arginine supplements. So arginine is a key amino acid that is basically your NO3 food source. And so by giving this therapeutic, which you can get over the counter, and by the way, Tom's of Maine by Colgate does have an arginine toothpaste, which I think is really interesting. I don't love the way it's formulated, but it's in market. You can get it. And I do love to think that it is helping, bolster the key species that you would want for nitric oxide production. I haven't seen any studies showing it, but I'd like to theorize. But certainly you could supplement with your diet. Vegans do show that there are more of those nitrate reducers in their mouths, and they have typically great heart health. Yep. Not always. That's another story. So there are, nutritional aspects to dental health that we've always known. There's nutritional aspects to heart health that we've always known, and that nitric oxide story ends up being a big part of that explanation from diet to heart health, what's happening.
It's so fascinating how, I think I said this on a previous episode, if we wanted to sum up our findings, it's going to come down to eat high fiber.
Eat high fiber, eat your vegetables, eat your beet juice. I know a lot of research is on beet juice.
Exercise,
yes.
and good sleep.
Yeah.
But getting back to the implications on heart health, right? It's one thing when you elaborated on that connection between NO and periopathologies and being able to manage that inflammatory cascade. Yeah. Whereas, like on the flip side, when we're talking about heart health and mortality, right? If we are not properly supplementing our nitrate and nitrite levels through, quote unquote, proper diet and whatnot, or not having that combined with, say, improper oral care hygienes, it really can exacerbate those cardio issues, especially as we age.
Yeah.
And I think that's, while it has been stated and seems to be understood in the cardio spaces, I don't think that connection has been highlighted enough. And this is one of the reasons why I was really excited to chat about this topic with you for this episode. And I have a feeling this will probably become something we will visit regularly.
Yeah.
Because
Well, we're learning so much at such a speed. We will have to do updates as we learn more because, this story isn't over. We're just starting.
right.
I think it's an exciting story. Those that know me know my stance. I'd like to move away entirely from an antimicrobial approach and really move into an anti-inflammatory approach. I know that ibuprofen is not the way to go. Aspirin does seem to have an efficacious impact on the oral cavity as far as inflammation, but I think there's other opportunities. Certainly, Forsyth research has shown that there are resolvins that could impact these inflammatory pathways. Haji Shingalis has done a lot of work in the complement space and inhibitors of complement that may, turn out to be fruitful for this space. So I'm looking at the inflammation side of the story to correct and balance those microbiome components instead of trying to remove them entirely because it turns out we need them.
Do you think, I guess you could make a link to cardiovascular health, but switching from that topic, do you think there's a link between NO, oral health, and neurological health?
Ooh, I mean, how could it not? First of all, blood health is essential for all of that communication. So, I haven't done a deep dive in that area. I was trying to do that today at the last minute, but I didn't get very far. But I definitely want to touch on the neuro piece of periodontal pathology because it's been well documented that periodontal pathology can impact your mood, cause depression. I don't know if it's direct or indirect, but I think there's a lot of biological pathways that are being impacted that have deleterious effects in many different directions. Is NO a direct or not? I don't know, but definitely could be.
Yeah, I'm excited to learn and see more coming from research in that particular space to see if there is a connection. I think it's undeniable is a strong word, but I think we're getting greater resolution of seeing how connected oral inflammation may be to impacting neurological health.
Right.
And
is it the inflammation itself, or is it the impact on the microbiome itself? Is it the NO? It's lots of different components, moving parts, if you will.
Mm-hmm.
But
and so beyond diet and exercise and sleep, our recipe for
and arginine supplementation
and arginine, are there any other methods or ways we could think about improving the NO story for our mouth? And this could be hella speculative. Doesn't have to be something that we've gathered from the research.
You covered dietary. Well, I mean, I would like to see all of our oral hygiene products move into a more thoughtful space of no irritants, really think about how we can reduce our impact on the oral cavity. So we already know that mastication alone can induce inflammation, and that eating less, like fewer times a day, there we go. If we eat fewer times a day, we impact our oral cavity less and have less inflammation. So anytime we can reduce the amount of inflammation that we're putting on our mouths, that would be productive. So if we had hygiene products that actually considered that element, I think we would be moving in the right direction.
That's interesting because I think there's one story that says you're always told chew your food, right?
I know.
Right.
Well, and you would want to if you want those bacteria to do their job, right? So you need to.
Mastication's important for getting the most out of your diet.
Right.
Right. Yet hearing less is more when it comes to, say, either the amount of meals or times we have episodes of mastication. I just wanted to say that.
Mastication. Absolutely.
Right. So, see, now that makes me think like, I'm sure there's some research there that looks at like those who do intermittent fasting
Yes,
versus
exactly.
those who
but
follow.
I don't know that we've taken that into the dental space really fully. And I think that it's an obvious next step, maybe just to me. I don't know.
No, I don't think it would be too difficult to perform such studies. And I would be really interested in seeing the outputs. So whether we're looking at inflammatory biomarkers, and especially if it's a longitudinal study,
Yes.
seeing like their metabolic profile and whatnot when it comes to sleep, health, and everything in between.
Right. Well, so the intermittent fasting, I think, is good for your oral health, probably, but you do have to consider activity. So a lot of the intermittent fasting communities are very active. And so if you're very active, then you get this demargination, like Dr. Glogauer was talking about, how you along your digestive tract, you have this demargination issue, and you can create inflammation that way too. So really being mindful of your activity spurts and your dietary spurts, if you will, and to minimize the inflammation, but optimize your efforts. Yeah, it's all about balance.
Oh, I love food though.
I know, me too.
I love food. So that is a lot to consider when we want to find what is considered the right balance.
And just for those listening, we have a bunch of snacks on the table, so we're about to masticate on those.
Yum, 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 yum.
Oh my God, this has been fantastic. I'm so glad we got to do this in person.
Seriously. I mean, we can go into the history of this right now, but yeah, this is, for those who don't know, this is the first time I've been able to see Camille since 2018, maybe?
Oh my gosh, has it been that long? Ugh.
Right?
Wow.
And so...
No, because I came out during COVID, at the end of COVID. I was, right?
We did see each other, but I thought that was before COVID.
Oh my gosh. I don't even know what happened. We all have collective amnesia over
Very
COVID
true.
times.
But moral of the story, it's been many, many years. And so on a future episode, I think it would be appropriate for us to kind of share an origin story for how we've met and how our journey's path, and if the audience cares, even our past before we've met, because I think it's very clear that we have a shared affinity for oral health, the oral microbiome, all things oral.
Let's get oral.
Yeah. That allows us to get oral with it.
Oh my God, we should close on that. Thank you so much for listening. Thank you, Jonathan, for playing with me. This has been amazing.
As always, Camille, I love doing this with you. This has been fun. Again, thank you for listening, and keep smiling.
All right, it's a wrap.
Let's get oral.
Hey there, listener. If you made it this far, we want to genuinely thank you for listening to Let's Get Oral and giving us a chance. If you haven't already, please subscribe to this podcast on your favorite streaming platform, leave a review on Apple Podcasts, Spotify, or anywhere else, and please share this widely with your friends, family, and coworkers. And if you haven't listened to our previous episodes, we highly recommend you check some of those in our catalog, such as the one we most recently published with Dr. Jonathan on focus on the role aging and oral health play with each other. Until next time, keep smiling.